Hey guys, welcome to another LeetCode tutorial. In this video, we are looking at problem number 101, that is symmetric tree. This is of easy difficulty and it's quite popular. By looking at the like and dislike ratio, um, yeah, it's disproportionate. So a lot of people like this question, and it's quite popular too, as it has been asked by big companies like Amazon, Adobe, and LinkedIn. So the problem statement says that you are given a root of a binary tree, that is the first tree, and all the subtrees are nested under it in the form of a tree nodes. So we need to check whether it's a mirror of itself. That means if you cut the tree into from the root into half, the left subtree and the right subtree should be equal. Okay. Now there's a if you try to think uh, just in terms of like a single tree root, the problem gets slightly tricky. But if you know one particular trick, you can, since it's the same tree, you can just imagine having two tree nodes, basically a copy of the original tree node. Let me highlight it here. So this is my original tree, and then I'm just, if I get the root, if I copy the same thing into a different parameter, I get the same tree, right? Because all I need is the root, and everything under it follows the pattern of left and right. So uh, although we have like a single parameter called root, I'm going to uh, build my recursive function and pass two roots into it, just by calling this root into two different names as root 1 and root 2, but the reference is still the same. Okay. Now let's talk about the approach of solving this programmatically. Now that I mentioned that we are going to use two roots, which are like pointing to the same reference, the way you need to check symmetry is, first and foremost thing is, since we'll be writing recursive functions for the tree problems. At certain point, you're going to hit the leaf nodes, right? So you're going to start off at the root. You're going to traverse to the left. You're going to traverse, and then there is another iteration or recursion that goes to the right subtree. One goes to the left subtree, and eventually you will hit the leftmost node, and you will hit the rightmost node, and then you are going to check for you're going to perform a root dot left on this, which will be null, and then you're going to perform a root dot right on this, which is going to be null. That means uh, if both the root values, that is, if there is no root, that means you have hit null for root 1, and you have hit the null node for root 2, then you can return true for that particular recursive function, because if both doesn't exist, then they are equal, right? Otherwise, there's another condition. If root 1 doesn't exist or root 2 doesn't exist, that means that if root 1 doesn't exist, if we have an or, that means root 2 exists, right? Um, then then it means return false. It's not symmetric. If it is symmetric, it has to be exactly like a mirror image of the root 1. The root 2 should be a mirror image of root 1's recursion, right? Now, the if it doesn't hit any of these cases, that means we are going through a node somewhere that is not a leaf node. In that case, what do you have to check? So in the example, I'm calling this root 1, and then this as root 2, right? We are having the same reference, but calling it with different names. And I'm going to use root 1 to iterate through the left half of the subtree, root 2 to iterate through the right half of the subtree, these three values. Now, um, now I have reached the condition where I haven't hit the leaf node of tree root 1 or leaf node of root 2. Similarly, I haven't reached a condition where, oh, root 1 doesn't exist or root 2 doesn't exist. I haven't hit null nodes or leaf nodes in either of the cases. Then it doesn't go to any of these cases. Then I have to check for root 1 dot val is equal to root 2 dot val, right? If you look for the first case, right? Let's start here. So 1, and then 1. So root 1 will be 1, root 2 will be 1. And are we checking if root 1 doesn't exist or root 2 doesn't exist? That's not the case. If root 2 exists or if root 1 doesn't exist or root 2 doesn't exist, that is also not the case. Then we are going to make a check called root1.val is equal to root2.val. Okay, this has passed. Now what we need to do is, since this is passed, you need to continue with uh, you're not done there, right? You still you have only checked for the symmetry at the at that particular node. Now you need to check for symmetry at the lower level nodes. So you're going to call the same function. So I'm just naming it check symmetry. uh, so let me call this check symmetry here. So this is my function definition, and then all of this logic will be within my um, function body. Okay. All right, so I have this, and then this takes root 1 and root 2. Okay, so I'm going to repeat the same thing, but if you look at it, this time what I'll be doing is I am going to use my root 1 dot left. If I'm checking my root 1 dot left, what should I check for root 2? It should be the mirror image. So when I do a left, I need to check the right side of it. So root 2 dot right. Okay, and we are not done there because we also need to check for our root 1 dot right. So you have checked the left side, but now you have to check the right hand side, right? So root 1 dot uh, so let me just copy this, and I'll say root 1 dot right, and then root 2 dot left. For example, if you are here on this node, you're going to check if 2 is equal to this 2. Then once that is satisfied, you're going to check for root 1 dot left, which is 3, is equal to, you're going to send root 2 dot right. That's for the comparison. You're going to check, send these two nodes into check symmetry. Only then it will pass. Similarly, you're not done because you need to send the right part also. You need to consider the right. So root 1 dot right, and then you're going to send root 2 dot left into check symmetry again once that is passed. So iteratively, you're going to do this for every level, and you are going to, if everything passes, this value, this three checks that you make, is also going to get true. So if everything is true, then your tree is symmetric. So I'm just going to use this function. Let me call it with function. Just copy this in here, and of course we just need to invoke this. Oops. So I just copy. So when we are calling it, we just call it with root, and same copy of root. Uh, During invocation, I'm just calling the same parameter twice, and then when it gets into the check symmetry, the reference names are root 1 and root 2. So ideally, it's the same tree. That is what I wanted to highlight here. Okay, now um, this should work with the recursive function. Looks good to me. Now we need to add one more condition where if root is null at the first, when the function gets executed and root itself is null, that is an empty tree, then you return true because empty tree is a symmetric tree of another empty tree, right? There's no left and right, everything is equal, so everything is null. So I'll return true. Okay. Yeah, I think this is what we have here. So let me just check everything looks good. Root 1, root 2. If both are not there, you have hit the leaf node. Uh, if either one is not there, it's not symmetric. And then if root 1 dot val is equal to root 2 dot val, yeah, and then you're recursively checking the different nodes in the correct order. Then I think we are all set here. All you have to do is return check symmetry. Okay, I'm going to go ahead and run this. Cool. So we have our solution accepted, or the test case is passing for these two roots. So I'll go ahead and submit it. So a solution has been accepted, and that is how you solve symmetric tree problem for a on a binary tree. I hope you have learned something out of this video, and the important thing is this part where you pass the same root uh, um, multiple times, so that is twice, and consider them as different root references pointing to the same root. And that's the trick of making it easier for us to um, think about the comparing whether these are like this is a symmetric tree or not. Again, as I've said, if you've learned something from this video, please give it a like and consider subscribing to my channel. And I'll be posting more problems, solving more problems on LeetCode in the coming tutorials. Thank you so much for watching, and I'll see you in the next one.